Hey, problem solvers, Colfax Math here. Today I was going to go over one of my favorite math warm-ups is to teach probability, expected value. It's great for kind of any age student. It's a great way to get students up out of their seats, having fun game, and then lead that into a little bit of probability lesson. This is kind of like my first day of class. I love this game. You split the students into groups of two, so you have two students together. They kind of face each other, they introduce themselves, they tell themselves a little bit about each other, and then the game goes, you put one hand behind your back, the other person put one hand behind their back, and then they throw out a certain number of fingers, and they're trying to add up to 7. So I call the game Magic 7. I've seen this done in other places. The only twist here is the probability behind it. So I'm going to say I throw out a 4, the person I'm playing with throws out a 5, that adds up to 9. It's a loss, a non-success. So that's a loss. I throw out a 1. They throw out a 5. And I think, oh, well, that doesn't work. There's no way to get to a 7. That doesn't make any sense. I throw out a 2. They throw out a 5. That's a 7. That's a win. They throw out, 3. I throw out 4. That's a 7. It's a win. So they keep track of how many times they win, how many times they lose. And then when that's all over, I ask them to make a prediction on what's the probability of actually getting a 7. Is it a random experiment to start with, or do you get better over time? We'll play the game for a little bit, and then I'll just talk about the probability behind the game. 1, 2, 3. What do you got? 5 and 4? 9. Okay, 1, 2, 3. 6. 1, 2, 3.
Close.
What do you got? 5 and a 1?
Yeah.
6. Okay. 1, 2, 3. We got 5 and a 2. 7. Let's do it one more time. 1, 2, 3. 6. 1, 2, 3. 8. Say, well, what's the likelihood of actually getting a 7? And they first throw out, well, there's no point in throwing a 0 or a 1. So we'll make the assumption that nobody's going to throw a 0 or a 1. So that means we have two players. We'll call them player A and player B. So we have two players, A and B. The first player is only going to throw a 2, a 3, a 4, or a 5. Those are the only 4 numbers they're going to throw out. And then the second player, if the first player throws out a 2, they could throw out a 2, a 3, a 4, or a 5. So there's 4 outcomes right here. You could have a 2 and a 2, a 2 and a 3, a 2 and a 4, 2 and a 5. Only one of these 4 outcomes is a win. There's only one 7 in there. And then same way, you could draw out a probability tree here. A 3, they could throw a 2, 3, 4, or 5. In this case, there's only one win, a 3 and a 4. So there's a win, 1 out of 4. And then a 4, same scenario. They could throw 2, 3, 4, or 5. Again, there's only one scenario, a 4 and a 3. That's my only win. If they throw out, if player A throws a 5, 2, 3, 4, or 5. Only one here, a 5 and a 2. If you make the assumption that it's a random experiment, it's also the assumption that nobody's going to throw a 0 or a 1, there's going to be 16 outcomes. 1, 2, 3, 4, 5, 6, 7, 8, up to 16. Of those 16 outcomes, there's only 4 wins. This one, 2 and a 5. This one, 3 and a 4. This one, 4 and a 3. This one, 5 and a 2. Playing this game enough, you're going to see that there are 4 successes out of 16 total samples, especially if you make that assumption nobody throws a 0 or a 1. And then that reduces to 1 in 4, or 25% probability on any given time you're going to throw a 7. After we've calculated this probability, I have the students play the game some more and keep track and collect some data and see how accurate it is. Again, it has to be a random experiment. If player A throws out a 5 every time, and they know that, player B throws a 2 every time, you have a 100% probability of winning. So if it's a random experiment, how far off of the expected probability are they? Great way to start the day. Great way to start math class, get the students up out of their seats, introduction to probability. And then from here, you could just leave it at that, or you could just go over a few ideas of probability. The probability of any event is the number in the event over the number in the sample space. So here the event is getting a 7. There are 4 of those. The sample space is the total outcomes, 16. You could talk about the domain of probability, that all probabilities have to be between 0 and 1. All right, hope this video is informative. Hope you have a great first week of school, back to school after COVID. We're back in class. I'm loving it. Hope you're back in class as well. And thank you for watching. If you liked the video, hit like. Thanks for watching.